Right now, without feeling a thing, you are being pulled across the universe towards something we cannot clearly see. Our entire galaxy, and thousands of others, are streaming through space toward a single mysterious region. Astronomers gave the unseen culprit a fittingly ominous name, the Great Attractor. In the cosmos, nothing is truly at rest. The Earth orbits the Sun orbits the galaxy, and the galaxy itself is hurtling through space. But when astronomers measured exactly how our galaxy moves, they found something they could not immediately explain: an extra pull in a particular direction. Our galaxy, with everything in it, is racing at about 600 kilometers every second, nearly 400 miles a second, toward one spot in the sky. That is faster than you could cross a country in the time it takes to read this sentence. And nobody could see what was doing the pulling. How can you tell? By measuring how galaxies move. The expansion of the universe carries everything apart at a predictable rate. But our local patch is moving faster than expansion alone allows, as if a great mass off in one direction were reeling us in. That extra motion gave the secret away. The pull points toward the constellation Centaurus, in the southern sky, hundreds of millions of light years away. Whatever sits there is heavy enough to tug a whole region of the universe off course. But when astronomers turned their telescopes to look, they ran into a frustrating problem. The Great Attractor lies almost directly behind the crowded heart of our own Milky Way. From our position inside the galaxy, that direction is choked with stars, gas, and dust, a brilliant, blinding wall. We are trying to see something enormous and distant, straight through the densest part of our own home. Astronomers have a name for this blind spot: the zone of avoidance, the band of sky hidden behind the Milky Way, where ordinary telescopes simply cannot see the galaxies beyond. For a long time, it hid the Great Attractor almost completely, like a curtain drawn across the very thing we most wanted to study. So we found other ways to look. X-rays and infrared light can pierce the dust that blocks ordinary vision, and radio waves slip through entirely. Bit by bit, using light our eyes cannot see, astronomers began to map what lay hidden behind the glowing band of our galaxy. And there they were. Behind the curtain sat a sprawling concentration of galaxies and galaxy clusters, far more crowded than the space around us. At its heart lies a massive cluster called Norma, anchoring a whole region thick with galaxies, all of it tugging on the cosmos around it. This region, centered a few 100 million light-years away, is the Great Attractor itself. A vast overdensity of matter, the gravitational low point toward which our whole neighborhood is sliding, like marbles rolling toward the bottom of an enormous, invisible bowl in the fabric of space. Yet here the mystery deepened. When astronomers added up all the mass they could find in the Great Attractor region, it was not enough. Not nearly enough to explain the speed of our headlong rush. Something even bigger, even further away, had to be pulling too. Look further along the same direction, far past the Great Attractor, and you find it. The Shapley Supercluster, the largest concentration of galaxies in our cosmic vicinity, hundreds of millions of light years beyond. Much of our motion, it turns out, is a fall toward that even more distant, even greater mass. So our motion is not one pull but many, layered together. We fall toward the Great Attractor, which itself drifts toward Shapley, all of it part of a grand cosmic tug of war between the great concentrations of matter scattered across hundreds of millions of light years of space. Step back far enough and a pattern emerges. Galaxies do not drift randomly. They flow, like water, along vast invisible channels carved by gravity, draining out of empty voids and streaming toward dense knots. The whole universe, on the largest scale, looks like a system of slow, majestic rivers. By measuring the motion of thousands of galaxies, astronomers learned to map these flows, to trace the invisible currents of the cosmos. And in 2014, that map revealed something breathtaking about where we actually live, and how vast our true cosmic home really is. They defined our home supercluster by the flows themselves, by all the galaxies that stream the same way we do. They called it Laniakea, a Hawaiian word meaning immense heaven. It contains 100,000 galaxies, stretches 500 million light-years, and we sit far out near one of its edges. Think of Laniakea as a continent, defined not by coastlines but by watersheds, the regions where everything flows toward the same basin. The Great Attractor sits near the bottom of ours, the gravitational valley toward which our entire supercluster of galaxies is slowly, endlessly draining. It rewrote our cosmic address. We are not just on a planet around a star in a galaxy. We are in the local group, on the outskirts of the Virgo cluster, in the Laniakea supercluster, sliding gently toward the Great Attractor. For the first time, we could draw the map of where we truly are. And yet, for all this falling, we will never get there. Because space itself is expanding, and that expansion is accelerating, driven by the mysterious dark energy. The distant Great Attractor is being carried away from us even as we fall toward it. We are chasing something we can never reach. In the far future, dark energy will win completely. The great flows will slow and stop as expansion pulls the superclusters apart faster than gravity can draw them together. The cosmic rivers will run dry. The Great Attractor will release its grip, not by weakening, but by drifting forever out of reach. So what we see today is a fleeting moment in a much longer story, a snapshot of a universe still flowing, still falling, before expansion freezes it all apart. We are lucky to live in an age when the cosmic currents still run, and when we can just barely measure where they carry us. And the Great Attractor itself remains stubbornly veiled. Even now, the densest part of the zone of avoidance hides galaxies we have never catalogued. Somewhere behind the glowing band of the Milky Way, pieces of the thing that pulls us are still waiting unseen to be found. Much of the pull, like so much in the cosmos, comes from matter we cannot directly see. Dark matter threads through these great concentrations, adding its invisible weight to the flows. The Great Attractor is as much a feature of the dark, unseen universe as of the glowing galaxies that trace it. It is humbling to feel it. A region so distant its light left before our species existed, reaching across hundreds of millions of light years of empty space, gently steering the path of our entire galaxy. Gravity, the weakest of the forces, ruling the cosmos on the grandest scale of all. We even see our motion written in the oldest light. As we rush toward the Great Attractor, the cosmic microwave background looks slightly warmer in the direction we are heading and cooler behind, a faint cosmic headwind. Our speed across the universe is printed onto the afterglow of the Big Bang itself. The story is far from finished. New surveys keep mapping the zone of avoidance, refining the flows, weighing the hidden mass. Some astronomers now suspect Laniakea itself may be only part of a still larger structure. The closer we look, the bigger our cosmic neighborhood seems to become. There is a strange intimacy in it too. Every galaxy in Laniakea, 100,000 of them, is bound by this shared motion, all falling the same way, all part of one vast flow. We are not adrift and alone. We are traveling together, a continent of galaxies, moving as one toward the dark. In the end, the Great Attractor is a lesson in how much is hidden. The largest motions of our galaxy are governed by a thing we can barely see, behind a curtain of our own making, woven through with invisible matter. We feel its pull long before we can ever picture its face. So the next time you stand under a dark sky and find the southern stars, remember that somewhere beyond them, hidden behind the glowing river of the Milky Way, a vast unseen mass is gently, patiently drawing you in. You have been falling toward it your whole life, and you never felt a thing. We are a continent of galaxies, sliding down an invisible slope towards something we have only half glimpsed, in an age when the cosmic rivers still run. We will never arrive, but the falling itself, measured and mapped across the dark, is one of the quietest and grandest discoveries we have ever made.